Okay, question 5. This is the first question really on this paper where they're trying to intimidate you. But they give you a very easy lead-in. We've got y as an easy polynomial, dy by dx really is just core 1 differentiation. Don't muck it up. Get 1 easy mark for that. Then in part 2 they give you a hint that this is going to be relevant. We've got to do an integral where that thing is the bottom of the fraction. And that should tip you off, together with the fact that the answer turns out to be a log, that what we're looking for is an integral with 2x squared minus 8x plus 3 on the bottom, whose answer turns into a log. So you need to look up in your notes, when do we get log answers to integrations? And the answer is that we have to do a particular kind of thing to the bottom of the fraction to get the thing on the top. And it's not unrelated to what you've done up here. So you know what expression you would like to be on the top of the fraction in order for the answer to be a log. And it's not quite x plus 2. In fact, it's a multiple of x plus 2. But what you do is you fill in the ideal expression that you'd like from the bottom, so that you know the answer is going to be a log, and then you put a particular constant in front of the whole integral that turns it back into what you wanted. So if you've had to multiply up what x plus minus 2 is in order to get your ideal expression, you divide by that same thing in front of the integral sign to make it work out. And then you can quote that the answer to this is going to be that same mystery number times a square bracket containing log of something. And you put your two limits in, 6 and 4, put them in the right order, subtract your two answers, and you're going to have to use probably a rule of logs in order to get the answer as a single logarithm times a number for 4 marks. Now if you couldn't do that, part B of this question is a great dirty big re-entry point. So forget all about part A, have a fresh go at part B, which is integration by substitution. Here's u, here's the integral we're trying to do the normal thing, really follow your notes for this one. Before you listen to the rest of this video, just look up integration by substitution in your notes, because this is a fairly standard example. You're going to start with your substitution u equals, and the first thing we always do is differentiated it, d something by d something equals, and work that through until you can get dx equals what you're going to replace your dx by. It's obvious that this is going to be replaced by something. Dx is replaced by whatever this is, and this x here, either it will be cancelled out, or if it isn't, you have to do a rearrangement to make x the subject of that, to put u's back in, and you have to substitute in, multiply out, and see it through to get the answer in terms of firstly u, and then you turn all the x's, the u's back into x's using the substitution. But as I say, you have similar examples in your notes.